Our topic for today's discussion is all about subset of real numbers. The learning target for today is at the end of the lesson. I hope you'll be able to say that you can describe, represent, and compare the different subsets of real numbers. Subset of real numbers are simply the combination of rational and irrational numbers in the number system. So this is a graphic organizer or a chart of subset of real numbers. So as you can see, rational numbers are composed of integers, whole numbers, natural numbers, together with fractions, decimals, and percent. On the other hand, irrational numbers are numbers which are non-repeating and non-terminating decimals. We are going to discuss this further in the latter part. So real numbers are any numbers that can be found on a number line. So this is an example of a number line. It extends to the left and to the right. At the center of this is 0. And in the left side are negative numbers, the right side are positive numbers. So real numbers are any numbers on this number line. See, for example, we have here square root of 2. It's somewhere here. Negative 1 and 1/2 is between negative 1 and negative 2. 3.5 is between 3 and 4. 3/4 is near 0.1. Negative 4.6 with a vinculum. As you can see, this line here, it means 6 is being repeated many times. Square root of 25 is equivalent to 5. So these are examples of real numbers. So real numbers are rational numbers, integers, whole numbers, natural numbers, and irrational numbers. So let's get into these topics. So real numbers are any number that can be expressed as a decimal. The symbol for real number is R, and all rational and irrational numbers are considered to be real numbers. Example of this is 2/5, 0.4545, and so on. Pi. So these are real numbers because it can be expressed as a decimal. If you know already, pi is 3.14 and so on. 2/5 in decimal form is 0.4. So any number that can be represented as decimal are considered to be real numbers. Under real numbers, we have rational numbers. And these are numbers that can be written as a fraction, P over Q, where P and Q are integers. And Q should not equal to 0. So this denominator should not equal to 0. Symbol for rational number is Q. In decimal form, these are terminating decimals and non-terminating repeating decimals. So when we say terminating decimal, it is a decimal that has an end digit. It is a decimal which has a finite number of digits or terms. So say for example, 0.261 is a terminating decimal. That is why it is a rational number, because the decimal has an end digit. So it doesn't go on forever or continuously, right? How about this one? 4.77 with an ellipsis. So it means this is continuous. Yes, it is non-terminating, but it is also a repeating decimal. So if it is non-terminating, I mean whether it is non-terminating, but if it is repeating, decimal, it is a rational number. Okay? So this is just an example of a graphic organizer explaining the decimal expansion. So if it is terminating, meaning it has an end digit, it is a repeating, they are considered to be rational numbers. But if it's non-terminating, meaning to say a decimal number that does not have an endpoint and its decimal digit keeps continuing forever and it's non-repeating, it means the number considered to be as irrational number. Okay? So I'll give you an example. So 0.32 is a terminating decimal. It means this is a rational number. What else? 0.111 and so on is a rational number. Even though it doesn't end or it doesn't have an end digit, but it is a repeating decimal, again, it is a rational number. Okay? Irrational number, the decimal has no pattern at all. For example, 0.1467 and so on. And it has an ellipsis, meaning it continues forever. It is considered as irrational. Last example, 0.345345 and so on. This is a rational number because it has a pattern which 345 is being repeated. So I'll repeat, if it is a pattern, even though it is non-terminating, it is considered to be as rational. If it has no pattern at all and it is not repeating or non-repeating, it is irrational number. So I hope you got it. So irrational numbers, when written as a decimal, these numbers do not terminate or repeat. So I've mentioned that a while ago. Symbol for irrational number is Q prime, meaning not rational. For example, pi. So pi, if you're familiar, it is approximately equal to 3.141592655 and so on. The digit go on and on with no pattern at all. So it has been calculated to over 100 trillion decimal places without a pattern to the digits. That's why it is considered as irrational. The Euler's number is also an irrational number. The value of E is 2.718281828. So like pi, it doesn't have any pattern. Negative square root of 3. So if you calculate it, it will give us a resulting decimal with no pattern at all. Okay, so that is irrational number. So let us now proceed with integers. Integers are all counting numbers, their negatives and zero. So we have here 0, the positive integers are positive numbers and negative numbers. The symbol for integer is z. Like some examples are 0, negative 28, positive 352. The set of positive integers is denoted by z positive, while that of negative integers is z negative. Whole numbers. All positive counting numbers and zero are whole numbers. So what differentiate whole numbers from integers is that it doesn't have the negative numbers. Okay, only zero and the positive numbers. The symbol for whole number is W. We have here 0, positive 43, positive 81. Next, is the natural numbers, all positive counting numbers. So in here, what differentiate natural numbers from whole numbers and integers is that it doesn't have zero, or the starting number is not zero, and it doesn't contain negative number. So natural numbers are also called counting because when we count, right, it is start or always start from one. So we count it 1, 2, 3, 4, 5. So those are natural numbers or counting numbers. And the symbol for that is N. Like +1, +28, +94. So to sum it up, this is a chart of real number system. Again, real numbers are just simply the combination of rational and irrational numbers. But in rational, there are integers, whole numbers, and natural numbers. Integers, the only difference is it has negative numbers. Whole numbers, the difference, it doesn't have negative, but it starts with zero. Natural is like counting numbers. Lastly, irrational numbers are numbers or decimals with no pattern at all, and it doesn't stop, or it has, it is non-terminating and non-repeating decimal. Okay, so I hope you understood that one. For your assignment in your notebook, I want you to create your own real number system chart or graphic organizer and give examples for every classification. And for assignment number 2, get your notebook again and copy and answer this one. You will identify the subsets of real numbers for each item, name that all applies. I'll give you an example. 1/5. Is 1/5 a natural number? No, right? Because natural is only from 1 and positive numbers or integer. Whole, is 1/5 a whole number? No, because whole number starts from 0 to positive infinity. Integers. Integers contain 0, negative, and positive numbers, so it is not an integer. Rational. So rational can be written as P over Q or just a fraction, so 1/5 is a rational number. And if it is a rational number, it is not a rational number, okay? Since it is a rational number, it is a real number because real number is just considered to be rational and irrational. Okay, so that is what you are going to do for this assignment. Again, if you have any question regarding the topic, you can rewatch the video, pause the video, or ask me in our Google Space group chat. Okay, that's all. Thank you now for listening.